Hello everyone, welcome to this webinar. Firstly, I hope everyone is safe out there, and if you are going out, make sure that you proper taking care of yourself and take the major distance, sanitize
Safe
yourself.
out there, and if you are going out, make sure that you proper taking care of yourself.
Uh, so today we are going to talk about the TensorFlow, which is very amazing, things with us, and we have the amazing and dynamic speaker with us, Rishit Dagli. So taking over to him. Go ahead. Rishit, you are muted. Please unmute yourself.
Oh, sorry, I was muted. I didn't notice that.
It's okay. It's okay. It happens, man. Go ahead. All the best.
Yeah. Okay. Hi, folks. I'm Rishit Dagli, and maybe you just heard that from Mehul introducing me. Thanks for coming here. Before we start, just that I've switched on captions from my side. You'll see them down over here, and uh, so you don't need to switch them on from your side. A bit about me before we get started. Uh, I'm Rishit Dagli, and I currently am a student of grade 10. I am also a TEDx and TEDx speaker. Apart from the things listed down over here, I've also participated in various hackathons and competitions, represented my country in them, and I've also won a few hackathons at the international level and competitions too. And furthermore, I love to conduct research, and yeah, I just love research, and I've also written 7 research papers. So away with me, let's get started. With that, let me just tell you who the ideal audience would be for this talk. It would majorly be people who have worked with some deep learning models, made a few models, could be Keras or core TensorFlow too, it doesn't matter. And um, developers who are looking for ways to make better models. So you want to improve your model and get, yeah, in short, just make your model to better perform on your problem statement. So that would be the ideal audience for this talk. Before we move any further, let's just discuss what we'll be doing today or the agenda for today. We'll be starting out with the motivation behind all of this and why you should care. We'll then see how you could use TF Hub. And finally, we'll see some cool demos which you could try out for yourself too. Demo which I am kind of excited about is neural style transfer. We'll see how you can do that yourself at the end of this session, and you'll also try to get the art. Also try it yourself. So let's start by the motivation behind TF Hub and how it can help you. So we all use open source code, right? We try to make it better, do some tweaks, make it work for us. And I feel that is the power of community. You can share your work with people all around the world, and people can use that work to make their own projects better, implement some of that work. And I feel that is the power of community. So that is the major thing TensorFlow Hub focuses on, making use of open source code, model, data sets super simple. So as a developer, you have ease of using open source models and data sets, and you can do it all of it very easily with TensorFlow Hub. As a result of this, you can also develop applications faster. So now you have access to the work that has already been done by other people, and you can leverage that in your app. So as a result of which you will be able to build applications faster, and not everybody has access to a high power GPU or TPU and train model for days. you can get started off by building on open source content using transfer learning. So we'll see what transfer learning is, how you can leverage that. If you don't know about it, there's no problem at all. So let's say you want to build a model which takes all reviews you receive on your product, maybe on your website, maybe on PlaySide and any platform, and takes all these reviews and see if they were good reviews or bad reviews, probably an NLP task. You can use word embeddings from a model trained on the Wikipedia dataset and do very well just in some time, instead of having to go out and build the model from scratch all by yourself. And this does very well in just some time. Uh, this was a very simple example to explain what is transfer learning and how you can build better applications with it in very little time. So we'll see about this in more detail and how you can do it for yourself. Having discussed about the motivation behind TensorFlow Hub, let us see now. Uh, so we saw about what you would want to do in your application and the motivation. So let us now see what TensorFlow Hub is. We have not come to the part like what TensorFlow Hub is and also why you should care about it. Modeling is an important part of any machine learning applications. You would want to invest quite some time, quite some effort, and but you should get this part right. So also note that I'm not saying that modeling is the only important part or thing in machine learning. In reality, there are a lot of like building. There are a lot of important parts like building pipelines, serving models. We'll not explore them now, but what I am trying to tell you is modeling is an important part, and it would be good if you can get this part right. You can see a GUI and friendly version of TensorFlow Hub at tfhub.dev. You can see Hub here itself. You can so again, why you should care. You can filter, so you have a wide array or collection of models over here. You can filter models based on the type of problem you want to work on. Maybe it's image, maybe it's video, maybe it's text. Uh, the model format you want to maybe have it on TF Lite, on TensorFlow.js, and also based on the publisher. So this is the GUI version of tfhub.dev, which lets you choose among and apply filters among all of these model types. So that can be found at tfhub.dev. I've listed out that URL over here. You could go to that URL and see the vast array of models that TF Hub has. And um, here you'll find a lot of well-tested and state-of-the-art models. So you don't have to go anywhere else, maybe hunt on some GitHub repos or hunt through some blogs. You don't have to do that anymore. You could just go to TF Hub and find a lot of state-of-the-art models right here on TF Hub. So just speaking of some state-of-the-art models, you have Inception, MobileNet, and those were just two state-of-the-art models. But you have a lot of these present right here at TF Hub. What is even better is that you can easily integrate it with your model APIs. So let's say I have a huge model. I don't want to go into the workflow that I download the model to my personal system and then get started with working on it, upload it somewhere, and do all of that. So with TF Hub, you can easily integrate it with your model APIs. So you want to have flexibility while building your models, and TF Hub helps you to do so. The standard model APIs are very much integrated with TF Hub. So that's another added advantage which TensorFlow Hub gives you. And also at TF Hub, You have a wide array of publishers too. This may be not the first thing of why you should use TF Hub, but it is good to know that you have models by leaders in the industry that have been trained using high-end hardware, lot of compute, maybe days of training, and made available for your use cases. So there are many more too, but these are the ones that fit in the slide. So don't get me wrong, there are not just six of these publishers. There are a lot of them, lot of cool companies, but just the ones that fit in the slide. So having seen what TF Hub can do and what TF Hub is, let us see why you would want to use it. You already have an elementary idea about this. We'll expand on that. We just talked about an elementary idea about building models faster, building quality models, building better applications. So we'll expand on that idea. So at this stage, a major question, before moving any further, at this stage, a major question that might come to you is, do I even need TFR? Like, I could always do a Google search, right? Something like image classification or object detection models, and you'll start seeing Inception, ResNet, Unit, and many more of these models. So now you might say, we discussed so much to get a no over here. No, that's not the case. Well, that is not the case. So remember we talked about an API with TensorFlow Hub. What it allows you to do is get or download these models in a usable format with just a single line of code. With the metadata like which layers I have, the description about model, and almost everything you are going to need. A cool thing about this is you also have a lot of code snippets in the model itself. So on TF Hub, if you see a model page, you have a lot of code snippets to help you get started on how you could use that model. And that is something really cool. You have a lot of well documented models, and you'd want to work with these kind of models. As I said, TF Hub allows you to do transfer learning. And what the idea behind this is, you take the weights which were trained on a huge hardware and retrain some of your neural network layers with your own data. So TF Hub allows you to do transfer learning just as you would write a simple neural network. You have worked with writing a simple neural network. TF Hub allows you to integrate with it, build further on it. So it's very tightly integrated with the standard model preparation technique. We'll see how you could do this, but but TF Hub allows you to do transfer learning very easily and is well integrated with the standard model creation. It also so doing transfer learning also allows you to achieve generalization in your model. So maybe I have some model which was trained on some A set of images. What my company needs is predict some B set of images. Now, some of the B set of images might also be in the A data set on which the model was trained on. But for my company part, I also need to have it generalized enough so that it can work well in real life scenarios. So with transfer learning, you could retrain some of these layers and achieve well generalization within your model. So uh, you can predict images which are not coming from the same distribution that the model was trained on. So transfer learning allows you to do that too. So as you have your embeddings or weights or convolutions learned pre-hand, you can train quality models with very less data. So Maybe if I go out to build a neural network all by myself, I would um, I would need a lot of data to feed in. To work in real life scenarios, I would need really a lot of data to train my model on. Uh, in transfer learning, you already have the convolutions or embeddings or weights pre-learned or learned pre-hand, and you can retrain the model with less data, and you can kind of compensate for the less data. You don't have to worry about getting more data, or uh, or having to spend more for the process of getting more data. So I'll repeat this again. Maybe it was um, a bit language kind of thing. You don't have to spend more on the process of getting more data. And of course, we stressed on this part. It takes less time. So if I maybe want to train a model from scratch, I would. So first thing is I would need a lot of images, maybe a million or more images. That we just covered that. I want to do it in less data. And the other thing is training a neural network on million data points or million images maybe, or million paragraphs according to the problem you're doing, but would take a lot of time. It would also take a huge amount of hardware. So transfer learning can reduce your time while you have a quality model or a model which does very well on your real life data built with you. So a lot of times what happens is uh, when you're building maybe say a huge project, your code bases become very dependent or coupled. So this can make experimentation and iteration process a lot slower. So when you are building an application, an AI application, what you want to do is you want to quickly iterate, quickly experiment, try that out, try the models out. So the AI process is all about doing experimentation and iteration as quickly as possible. So if you have like a lot of dependencies in your code bases could become very dependent. So dependencies become dependent. Yeah, that kind of rhymes too. But your code bases could become very dependent or coupled. And uh, as you might have also thought, your experimentation and iteration process becomes a lot slower, which is a very bad thing in a team to do. So TensorFlow Hub defines artifacts for you. These artifacts are not dependent on code. So you have a system which allows faster iteration too, as the artifacts provided by TensorFlow Hub are no longer dependent on the code. So you can have your team do faster iteration with the pre-trained models from TensorFlow Hub. Another cool thing is it does not matter if you use high-level Keras APIs, the Keras.layers.sequential, maybe the first thing a lot of you might have learned while starting out with neural networks, or even low-level TensorFlow APIs. You can also use it in your production-grade pipelines or systems. TensorFlow Hub integrates quite well with TensorFlow Extended too. And TensorFlow Extended helps you build production grade pipelines. So it integrates too well with TensorFlow Extended too. And you could have a production grade pipeline ready with TensorFlow Hub too. You can also use tf.js or TensorFlow.js models for web-based or node-based environments. So you have a model which runs just in the web itself using tf.js. TensorFlow Hub has models. Uh, TensorFlow Hub also has tf.js models for node-based environments. So you are covered in that manner too. And nowadays, you might have heard about the hype of edge and edge machine learning taking off due to the privacy latency concerns. We'll not go into edge a lot now, but edge ML is taking off quite well too. So you can use TF Lite pre-trained models to run your models directly, maybe in a mobile device which has low compute or very low power embedded systems. So you can maybe run your TensorFlow model on a Raspberry Pi or Arduino with uh, and TensorFlow Hub provides you models for that too. You can also discover models for Coral Edge TPUs. It is essentially just TF Lite and combining it with the powerful Edge TPU. So, with Coral or Coral devices, you have a powerful Edge TPU, which gives a lot of, I would say, a lot of acceleration for Edge devices. And TensorFlow Hub has you covered for that too. You can discover models which run well on Colab too, and that's just great. The the amount of platforms on which you could use TF Hub to run your model, and it is tightly integrated with all of this. Now that you know what TensorFlow Hub is, why you should use TensorFlow Hub, and why it could maybe even help in your scenario or your problem, let us see how we can actually use this in our problems. So we discussed about we discussed about things like why you would want to use TensorFlow Hub, but we never saw it in code. So let's go ahead and do that. Let us before we jump into the core code, let us start by talking about transfer learning. We are, I just said, transfer learning is a way for you to do this and this. We talked about that, but I never went into things like what transfer learning is and how it could help you. So transfer learning is essentially the thing which gives the kind of power to TensorFlow Hub we talked about earlier. We also talked about how making any model from scratch requires all of this. Right choice of algorithms. So you need to have someone who can make a right choice of algorithms. You need to have a lot of data. You need to have a lot of compute to train your models, and at the end you also need to have domain expertise. So just demonstrating domain expertise, some of you might be wondering how domain expertise comes into this. So maybe you might have heard about um, AI models which are used for medicine. So just an example. So if you have an AI model which can run, which can be used to know what would be a patient's health, you cannot use the normal accuracy term uh, which we use as a metric for my model. I cannot use a simple accuracy. So why is it so? A domain expert, you need domain expertise to build your AI application in a better manner. So you need all of this, and we talked about how you need all of this in when you're building a model right from the scratch. So, so let's understand the TensorFlow Hub scenario. So there's someone who uses all of this algorithm, data, expertise, and compute, and makes what is called a module. So the module here is represented by the square, and so he uses all of this and makes what is called a module. So some part of this model which is usable. So you have some part of the model which is reusable. So in case of text, we may say the reusable part is word embeddings. So word embeddings give a lot of power to text, and uh, learning these word embeddings can require quite some compute to train. In case of images, maybe it could be features or just weights in case of numerical data. So you have those reusable parts, and you have all of this reusable part from a module in the TensorFlow Hub repo. So I'll just put all of this reusable part in the TensorFlow Hub repo. Now, with transfer learning, this reusable piece or this reusable piece could be used in your different models, and it might even serve a different purpose. So maybe and this is essentially how you would be using TF Hub, using the reusable piece in your model. So you have built you're building on top of that reusable part. So when I say this reusable part could have a different purpose in your model, what I mean is the original model could be a classifier, maybe trained on 1,000 labels, but for your use case, you just use it to predict or maybe do a distinction between three classes. That's just one example, but you now maybe understand about how it can even perform different tasks for your problem statement. Now let's get our hands into some code and see how is it implemented in practice. To get started, you need to install the TensorFlow Hub module. And installing the module is pretty straightforward. You can do a pip install. There are some other ways to. So we'll not waste time over the installation part. And you can see the installation process, and you can find the detailed instructions at this URL. So I'll give you kind of a moment to take a screenshot or go to this URL and or make a note of it simply. All these steps for installing TensorFlow Hub are well listed over here, and we'll not waste time over that. Okay, so I guess you might have uh, taken a note of this URL. So enough talking. Let's go ahead and see how you could do this in practice. So so anytime I want to start by loading my model. So we would start by loading models, and TensorFlow Hub makes it very simple. You don't have to worry about anything. You pass in the model URL. We'll see where you can find this model URL in the demo section. But for now, understand it as a model URL such that. Uh, so essentially, this would be a tfhub.dev model URL. And you could find this by searching on TF Hub itself or even through the repo. We'll talk about that in the demo section. And having the URL of the model and TensorFlow Hub installed, what you could do is simply call the method hub.load. So when you call the method hub.load, what it will do is it will go ahead and fetch the model for you, and it will load it into a trainable format. So when you call tfhub dot so it's not tfhub dot load, it's sorry, my bad, it's hub.load. I just said it downloads the model for you, and you'll notice that it is a saved model directory. So you would have your download something like this. You can notice it's a saved model directory, and you have your model as a protobuf file, where as a protobuf file which does the graph definition for you, and just a simple saved model directory. So it's also great to know that TensorFlow Hub downloaded the model in a format which was usable by me. So I can easily go ahead and use the saved model format. And there are quite a few things to take care of, and more things that TF Hub has to offer to you. But it loads the model in a format which is easily usable by you. There's another cool interface, which I like a lot. Personally, I like a lot. I find it pretty useful, and it's called the Saved Model CLI. Uh, I have personally used it quite a lot to uh, know what's actually going on behind the scenes. So what this will do is give you a lot of useful information about your saved model, like operation signatures, which you might have a use for. So if you didn't know this tool, it's a really good tool to explore your saved models and saved model directories. So you could just execute this code, and it also lets you know the operations or the signature definitions and your input output shapes. So the input output shapes is the part where it really gets exciting. I So if anytime I have some problem like the shapes do not match, which actually happens quite sometimes, I just go ahead and look up the saved model CLI output and see, okay, here's the part where I'm actually making a mistake and things like that. So this might be pretty helpful. This is just the sample output which you might receive from it, and you can see the input and output shapes being listed down over here. So you can now do inference directly. So you don't have to do anything more by so the model I just loaded was an image model. So you can do inference directly by passing an image to the model. So this would work with TF TensorFlow version 2 only. So for TensorFlow version 1, you'd also have to enable eager execution. And TensorFlow version 2, point X, which is the latest, it is enabled by default. Never mind. Just if you're using TensorFlow 1, you'd have to add a eager execution. So the model is already trained. I can directly pass an image to it and get my predictions. I'll give you a moment to think through this. Would it be the right kind of approach that we should use, or are we missing something? I'll give you a moment to think through this. So just think about, are we missing something? Kind of just go back to the process I had talked about. Let's go forward. Well, this is a bad idea because remember we discussed earlier, we want to generalize our models. This may work, this may not work too well for the kind of problem you are trying to address. So we'll use transfer learning again. You already know the intuition behind transfer learning and how it works. Let's put it to practice. Hub makes it really easy to create a keyless layer. So we'll be talking about high level APIs, as I guess a lot of you might have built models with high level APIs. So we'll be talking about how you can use high level APIs to build uh, to build a model out of this. So Hub makes it really easy for you to create a keyless layer directly from the model. So you can use this keyless layer uh, directly in your neural network. So this is just like any other layer, just like any other keyless layer. You can directly input this in your neural network, and that's just really cool to see because just think about it: the level of integration you get, the ease of access you get. You have to do almost nothing more, just as any other keyless layer. You just do a hub.keyless layer, have the module handle, and and make a keyless layer. So also note I'm adding the shape 3 for this over here because I want my model, so I want my images to have three color channels. So RGB, three color channels. So I'm adding the three to it. If you maybe have some, if you maybe don't have some image models, you won't add three. How to tackle them, we'll talk about them, but this is something which you do for color images. I thought just to talk about this edge case. So you need to add a three for the color channels too. A lot of times it is actually better to use image feature vectors. So what you do in an image feature vector is you remove the final classification layer from the network, from your neural network, and allow you to train a neural network on top of that. So you remove the classification layer, which gives you like your final output, the probabilities. You remove that and train on top of your other layers. So let's see this. We can have, so we can then have our model add a dense layer after it. So you are taking a standard model, adding your own layers to the model. As you can see over here, I'm adding some of my own layers to the model. So the first layer, of course, is the hub.keyless layer, and you can see a few more arguments. Trainable equal to true, which means I want to retrain this, and I can also see the output shape. So why the output shape was not there earlier and is there now? So now I want to train a neural network on top of this. So there would probably be a layer or two under this layer. So I would need to specify a standard output shape too, which could also be known as your feature vector size. So of course you could have multiple layers or even convolution layers below this, and but here's an example with a dense layer. So I'm adding a dense layer to my model uh, below the model, and then you could compile it like any other keyless model. After compiling it, you can also use the standard model.predict. So remember us talking about the API being closely knit, and here you just saw that it was very easy to integrate it with standard functions. The compilation and fitting part remained almost the same. You'll still compile this model like any other keyless model with a model.compile, adding your loss function, adding your optimizer function, your epochs, learning rate, and things like that. You can compile it like any other model. Oh, so I just mentioned epochs in the compilation part. Forgive me for that. It just kind of slipped out of my tongue. Uh, so in the model.fit method would just remain the same too. You would again add your training data, validation data, epochs just in the normal way as you did for any other keyless model. And that is how closely integrated and closely knit TensorFlow Hub is with standard model functions. And you don't have to go out of the way for creating compatibility with it, have compatibility issues, do a lot to train your own layers on top of it. You don't have to do any of that. TensorFlow Hub helps you. We saw about what what different would you want to do for an image based models. That is, use feature vectors or image feature vectors as you like it. Let us see what you would want to do in case of a text based models. So of course I can't use image feature vectors, and remember us talking about embeddings. We'll see how TensorFlow Hub allows me to use embeddings for my NLP tasks. So some of you might be knowing about this, and bear with me for a little while. So one of the major problems we need to address when converting text to numbers is a way to preserve the meaning or semantic of a text. So you want your model to understand the sarcasm in a sentence. You want your model to understand the semantic of a sentence, not just plainly the words. So maybe there's a sentence: I do not hate the product. The model should not take the word hate and classify it as a bad thing. So you need to understand the semantics of a sentence when you convert it to text. So we often use what is called word embeddings to do so. So as you can see, word vectors are, as the name suggests, you try to convert your data into vectors, and semantically similar words have a similar direction of vectors. So if two word vectors have the same direction, they mean semantically same, or semantically similar would be a better way to define it. So that is how word embeddings and word vectors work. The dimensions or the size of vectors are also called the embedding dimensions. So most part of training in a NLP task or a text-based model task is about learning these embeddings. So yeah, this is a representation of how embeddings in a data set looks like. I feel this is a good representation, and all of the code is open source at my GitHub repo. You could go ahead and try it out. I'll be sharing that repo. But let's continue for now. Again, TF Hub has not just, we discussed about image feature vectors, and TF Hub has a lot of these embeddings for you, and pretty powerful ones too. So maybe you have the Genius, which has 20,000 dimensions and was trained on 130 gigabytes of data. So this is one state of the art model hosted right there on TF Hub, which you can use for your product. Or maybe you have the NLLM dataset, which NLLM word embeddings, which has a vocabulary of million words. And there are many more too. Just select the category to be text, and you'll receive a whole array of text-based models. So there are many of these models right here on TF Hub for you. So let's get on to the code part and how you do this in practice again. And we'll majorly focus on the differences between them, between any other model and a text-based model. So the loading part is where things get a bit different. So you do something like this: specify that you are loading embeddings, and then you're all ready to use this in your neural net in pretty much the same manner we did earlier. So as you can see, I've just added a few things like image feature vectors were essentially numbers, but uh, so I've added a few things like data type, and I've added the data type part. So that was the difference I would do for loading for loading embeddings out of TF Hub. So you can see that there was not much difference between between the two of these scenarios, but it is good to know how you could handle word embeddings in a different manner than standard models. There's in fact another added feature with this. So let's say I'm using an embedding layer, which returns me 20-dimensional embedding vectors. This means if you pass in a single word, it returns you a 1 by 20 array. So actually, uh, you don't have to see those numbers down here. They probably don't make sense to you. Guess what? They don't make sense to me too. But what I want you to see right here is the shape part. The shape part is 1 by 20. I added in one word and I get a 1 by 20 array, which is 20-dimensional embedding vectors. Cool. So what should happen if I added two words? So let's say I pass in not just two words, but two sentences instead. I want you to take a look at the output shape which I get from this. The output shape is 2 by 20. So the 2, of course, is because I have two sentences. So embedding vector for sentence number 1, which is this is sample text, and embedding vector for sentence number 2, which is sample text 2. So that is what the 2 stands for. But why do I have a 20? Now, this might be pretty intriguing. 20-dimensional output vector should be there for each word, as we just saw. We just saw here hello giving us a 1 by 20, so 20-dimensional embedding vector for one word. So, so why do I have a 20-dimensional vector for a complete sentence which has almost 5 words in a sentence, and the next sentence has 2 words? So why do I have only 20 dimensions for them? So what TensorFlow Hub does for you is, this is again an added feature, so you don't have to worry a lot. So what TensorFlow Hub will do for you is it will intelligently kind of convert these word embeddings to sentence embeddings for you. And you no longer have to worry about things like keeping the shape constant. So if there was, if in a sentence you would still be doing word embeddings, you'd have to care a lot about the shape which it returns and maybe reshape it, things like that. And believe me, sometimes it causes a lot of problems. You have a lot of errors. Shape is not constant, can't specify the shape, and a lot of these things. I don't want to I don't want to do that. I don't want to waste my time over these things. I want to instead spend my time over writing my real application or my application code. So TensorFlow Hub intelligently converts these to word embeddings for you. And what do you have to do for this? Nothing. TensorFlow Hub provides this for you just when you call the uh, just when you directly access the method. TensorFlow Hub has this for you. You have to do nothing for this. So again, that's a cool added feature with TensorFlow Hub, making life simple for us. So let's now get to the fun part, which are demos. So we'll be seeing 2 demos for the day. All of these demos, source code is available in the GitHub repo. I'm sharing the GitHub repo URL with you. Just I'll give you a moment to kind of take this down or take a screenshot, take a note of this. And this is the GitHub repo specifically for this session. So I'll give you a moment. You can take a note of this GitHub repo. It will redirect you to the GitHub page for today's session. Okay, I guess you might have taken a note of this, and let's continue. So as I said, we'll be trying out 2 demos today. The first demo would be text classification. So we'll be seeing how we could use word embeddings and things like that in our model. And the second one, which I'm really excited about, is neural style transfer. So if you don't know what neural style transfer is, hang on. We'll see how cool neural style transfer is and what it can do for you. So I'd also urge you to try these demos for yourself to get a better understanding. You can run these demos on Colab itself. I have a Colab link to these demos right there in the GitHub page too. So you can run this out for yourself in the Colab too. So let me just switch my screen and get on the demos part. Okay, I'll quickly switch my screen now so I can get on the demos part. Yeah, here's it. Okay, I've switched my screen. You can maybe now see my screen, right? Okay, I guess my screen is not being displayed. Mm, I don't know. Mehul, could you check that out? I think my screen is not being displayed. Mehul? Um, I don't know. Let's just wait a sec. Is my screen visible to you? Just give me a yes or no in the chat, maybe. Is my screen now visible to you? Okay, I guess it is now visible to you, right? Cool, cool. Yes, my screen is now visible. I just figured it out. Cool, cool. So here is the TF Hub, a TensorFlow Hub, a GUI version. As I said, you could filter out by a problem domain, by a model format. You have tf.js,
Yeah,
TensorFlow Lite.
your screen is already displayed.
Cool. I just saw
Like,
it. There might be some technical issue. Never mind, it's visible now. Cool.
your screen is displayed actually. Right.
Yeah, yeah, I saw it now. So you have all of these model formats where you can choose from. I'll not actually go into the GUI. You can explore that for yourself. Nothing great actually.
I
Let's
can see
get
the
on to,
yes. I can see yes.
yeah, yeah. So um, yeah, my screen is now visible, so that should be great now. Yeah, let's just continue. Cool.
Yes.
So this is already present in the GitHub repo for you. You can even see it's already for you in the collab version. So what I'm doing is I'm using GCP AI platform to speed up things over here. But I understand that all of you might not be having access to this kind of hardware. So the complete code is written in a uh, collab friendly environment. I even have the button in here. The same code is in the GitHub repo another time. You could run the same thing in collab too, and it's collab friendly. I'm just using this over here so I can speed things up during this demo. So what we'll be doing is having an NLP. We'll be doing some NLP task. We'll be doing text classification. So let's just go ahead and do the URL importing things. So I just load the IMDb dataset, which is movie reviews dataset, and we'll see how we can specify. Okay, uh, this comment is a bad comment or hate comment, and this is a good comment. So with TensorFlow datasets, you don't need to know much about this. A lot of you already might be knowing about TensorFlow datasets. I have um, kind of downloaded the IMDb dataset. So this part, as it is downloading the complete dataset, might take some time. So I have already ran this for you. Let's get to the part. So as I can see, my IMDb dataset has two classes, which are I would say positive class or happy comment, and negative class or hate comment kind of thing. So I can see two classes, and I have 25,000 movie reviews for training, 25,000 movie reviews for testing. That's about our dataset. I'll just specify the class names over here. As I said, just two classes, one or zero, negative or positive. So we have those over here. And let's just print out anyone a movie review. So I can see that this is a movie review right from the dataset itself. This is the part. I'll zoom in a bit. Cool. I guess it's too zoomed in. That was visible. Yeah. It's visible. Okay. So the oh yeah. So this is, I've just kind of displayed a single piece from my dataset, so I can know that this is a lot of sentences as one of my entry. So and it is a negative label sentence. So this was just one entry in my dataset to know what my dataset looks like. So my dataset, one entry has a lot of sentences in it. So let us load the word embeddings. So I'll go to this URL. So I can see that so on the TF Hub GUI, which I can see over here, I have, so I just navigated my way through TF Hub GUI, stumbled, so selected that text model part and stumbled on this one model. So I have this model page over here. I can see it's trained on 130 gigabytes of data on English Google News. So there are quite a few things you can do to do things like you train your model in English and it predicts things in Arabic or French. But we'll not be doing that for now. We'll keep this demo simple, focus on making how you can do things better with TensorFlow Hub. And I can see it's a text embedding. So it has a lot of text embeddings for me. So this is a Google News dataset. And what I can also see is there's a cool documentation for it. So I have a lot of these code snippets telling me how I can load the model. And so that's something wonderful. You have a lot of well-documented, well-tested models. So what I would do is just copy paste this URL into my hub.load. So I'll add the embedding URL, and I'll make a hub layer from it, which will be a keyless layer. So, and note I have specified training equal to true because I want to do transfer learning on top of this. I want to add my own layers to the network. So let's go ahead and do this. Okay. So this is the demo I showed in the slides itself. Let's see how it looks in the real life. I'm running it in front of you. I can see the shape is 1 into 20 for a single word. For two words, it's 2 into 20. I showed you how TensorFlow Hub intelligently converts word embeddings to text embeddings while we were in the slides part. So this is not something which we'll be focusing on for today, but it's just some data pipeline part where you'll see how I load the data. If you're interested in this, take a look at the GitHub repo. All the code is written for you. You can take a look at this. What we'll be focusing on is making a model from this. So here is the part which I'm most excited about. Remember the hub layer which we declared earlier? we said it was a keras layer built directly from the data set I have over here. So I did not have to do anything, integrate it as any other keras layer right in my sequential layer. So let's go ahead and make a model. So the model training takes almost 60 seconds or 1 minute to run. I have kept the demo for you so that you can get done fast. So the GitHub repo has the model which runs in 60 seconds, almost 60 seconds, depends on your hardware. So you have this over here, or this again ran in a minute. And another thing I want to show you is let me first ask you, how do you compile and fit a normal keras model? You just use model.compile, model.fit, and I'm using the exact same thing over here. You can see how tightly integrated it is with standard model creation APIs. So to speed up things, I have already done the training process for you beforehand. And you can see, let me now go ahead and get my test accuracy on this. So what's that? Oh, it seems like the model training was in some other environment. What we'll do is we'll quickly leave this for training, and it should not take much. It's just a minute. So while this trains, what we'll do is we'll take this on from we'll take this on next. Yeah, I've already got the hang of it, how you would classify word embeddings. And while this model trains, what we'll do is we'll go to the demo number 2, which is neural style transfer. Again, this is Colab. This can entirely run on Colab. Just click the open in Colab button right there on your right there in the GitHub repo. So if you don't know what neural style transfer is, I have one image, I have image number 2, and I create something like this. So I don't think an explanation is required, but if you want to kind of get how it works, I'm trying to use the style of this image to paint this image. So you can see I have a similar style in this image. So this might seem like a hard task to do, and believe me, it is a hard task to do if you start by going to build a model from scratch. It requires quite some time and quite a few things you need to do. So what we'll do is we'll start by seeing about how TensorFlow Hub, with TensorFlow Hub, how you could do this. So like any other thing, let's start by importing. So here I have in the repo itself, I have a few images for you. So here are my images and styles. So some of you might now tell me this is a very bad practice. I know that, but I just have some 5 images. And to make things more transparent for you, I have included the real names of the images. So I have an image of a dog. So when you are trying this out after the session, things become more transparent for you. You can know exactly what you are doing and you don't have to frantically search for it. But as I just have 5 images for the demo, I have specified them manually over here. Let's go ahead and run this. So this part tells where my images were. Let's show 2 of these images, any 2 of these images. So I showed image number 4 and image number 3. Array start at 0. Okay, that was not required, but maybe let's try seeing some other image. Oh, okay, that's Mona Lisa and another style image. So that were just a few things. So another thing to note is what I'd get from my model would be a tensor. What I need to feed to my model is going to be a tensor. So I need functions which can convert my image to a tensor, because the user is going to give me an image and the model is going to return me a tensor, and I need to show the user an image. So I'll specify these two helper functions which will do the image to tensor and tensor to image part for me. As I just said, let's use these helper functions and convert all the images to tensors. Let's do that. While this does, um, again, I'll go to tfhub.dev, uh, the GUI part of tfhub.dev. It's taking, okay, yeah, it's loaded. So I browse my way through the GUI, got this page, got this model page, and I can see I have an arbitrary image stylization model. So let's go ahead and use, oh, what's this? Ah, seems like an error. Let's run this again. Seems like it went out of memory. Never mind. Okay, never mind. I've already run this for you. You have it. Right. I ran this for you. So sometimes it takes some more amount of time and resources have not been allocated. So I'll just load my hub module as simple as this. So what we just did was we did a transfer learning. So we just did a something with transfer learning, right? And now what we'll try to do is see. What's this again? This should ideally work. Okay. Okay, seems like some environment issue while I was testing this out. What I'll quickly do is show you the code in my GitHub repo. So I have a fallback plan. So seems like a couple or two of my environment variables might not have been specified correctly. I'll show you the thing right here itself. So this is loaded from Colab itself. I just showed you the module which was used to build this, which I got from tfhub.dev. Copied the URL from here, put it into hub.load. So then so we just saw, as I was saying, we just saw an example of transfer learning. And let's see what hub modules have to give me, what I can do without transfer learning too. So I have just simply called the hub module, specified my image tensor, specified my style image tensor using the helper functions we described earlier, and I'm just passing it into the hub module. So you can see an example. I had an Android G photo and a style. So this style is style number 2. Let's see what that style is. So I had this style and the Android G photo, which was, oh yeah, here's the GitHub repo. I'll just show you the photo that was used to build this. So this was the image I had, and this was the style I had. So I combined them to build something like this with neural style transfer. And you could see it was so easy to implement this. You did not need to have any domain specific knowledge. You could just use with TensorFlow Hub. So that was it for the neural style transfer demo. And let's go ahead. My model should be trained by now. Oh, it's trained. Cool. And let's go ahead and see my evaluation or my test accuracies for this. So with so I can see my losses around 0.327, accuracies around 86%. You might tell this, okay, isn't it like it should be at least higher with the TensorFlow Hub model, which is trained on 130 gigabytes of data. But just remember, if you see, I just have 20 epochs over here, and each epoch is almost 4 seconds. Okay, so maybe 80 seconds. In just 80 seconds, you could land up at such a good accuracy. So I have tried this out with hundreds of epochs, and the accuracy goes well over 95%. I have kept the thing short for you so I could show it to you on the demo screen itself. But try working your way around with changing the epochs, adding some more neural networks to it. But it's really cool to see in just 80 seconds we reach to 86% accuracy. So that's what TensorFlow Hub has to give to you, such high accuracies. And you can and I've directly used a module right there from TensorFlow Hub. So I feel that was something really wonderful TensorFlow Hub had to provide to me. So that was about the demos. Let's switch back. So again, I would advise you to try these demos out for yourself, and also uh, try working try working your way around these demos. Try experimenting around these demos. See what you could do with these demos. See what you could do more, I would say. And let's do a quick recap of what we just did. So my screen should now be visible to you back again. Okay. Okay, my screen isn't visible, but it's completely okay. And let's do a quick recap. It might take some time to come here on the live stream, but that's okay. Uh, so uh, it will just give you a way to take a glance over all of this, over all what we did. We first saw the motivation behind TensorFlow Hub. When you have less data, also when you want to build things faster. We then saw what TensorFlow Hub had to offer for us: a lot of modules with good documentation and code snippets, and even complete sample codes. You also saw why you should care about TensorFlow Hub. We then took a look at transfer learning and how it works in details. The thing you essentially do for using TensorFlow Hub models. So we saw transfer learning, which is the thing you essentially do for using TensorFlow Hub models. After which we saw how you could do this in in code. We saw how this works out in practice. Cool. So now my screen is visible to you. Might take some time to come on the live stream. Never mind. We saw how you could put this in code. We saw we started out with how you can load modules and do transfer learning. We then saw how you could load feature vectors in case of images and embeddings in case of text modules. And then we saw demos about text classification and neural style transfer. We built particularly good systems in just a minute or so of training. With TensorFlow Hub, this was possible. So uh, that was a quick recap of what we did today. And with that, I would now like to take questions if you have any. So now I'd be ready to take some questions and answer them. Okay. So let's see, what questions do I have? Okay, so I have got a question, uh, which is uh, any. Okay, now, okay, that was a statement. Sorry. Yeah, I've got a question from Rajat saying, can you please again explain why only two words have 20 dimensions? So, yeah, that may seem like a bit awkward at first. One word having 1 by 20, having 20 dimensions. So, two words should have more than 20, right? But what TensorFlow Hub does for you is it intelligently converts those word embeddings into what's called sentence embeddings. So you don't have to worry about things like managing the shape and things like that. You no longer have to worry about that. As TensorFlow Hub now um, TensorFlow Hub now does the sentence embedding part for you, a part of doing just the word embeddings. So it intelligently does this all for you, and that is why it had uh, just it had so that is why two words or even a whole sentence had just 20 dimensions. I think that answered your question, Rajat. So also, Mehul, do we have any more questions, or how's it? Okay, so there's another question now coming up by Frank. He's saying, is there a precise architecture for training models from scratch using TensorFlow? So when you want to train models from scratch, the thing is that you need to have domain specific knowledge. So if you are doing something like training image models, you need to use convolutional neural networks. If you're training text models, you would maybe have to use some word embeddings. And as far architecture is concerned, recurrent neural networks or LSTMs, that is what you would have to use for text models. So it actually depends on the kind of problem you are aiming to solve. And so there's no one single architecture that can define all. And also you might have heard something similar to this, where which actually explains this, which is called the no free lunch theorem. There's not a particular single algorithm which can solve all types of problems. So you have no specific architecture to solve all kind of problems. So it would actually depend on the kind of problem you are aiming to solve. And on TensorFlow Hub, you have things for almost all kind of problems you could work with. So I guess that answers your question, Frank. And um, I think we had just these questions. Or do we have any more, Mehul?
No, I think we have that much only. Yeah.
Okay, cool. So uh, again, thank you all for attending this session. It has been a pleasure to talk to you, speaking about how you can make better models, build faster, build your applications faster, and the major part, which is you focus on building the real application and not focus on things like I have an I have a shape mismatch, and my embeddings do not match, or I don't have enough compute. So that is what TensorFlow Hub aims to do for you, and I hope this might have been wonderful for you. Go there, check out the GitHub repo, do those demos for yourself, and um, also if you build something cool with TensorFlow Hub, use it in a project. Be sure to share it with me. I had shown a few of my I had shown a few of my I had shown my Twitter handle. I'm most active on Twitter and LinkedIn. Find me on any of them. Tell me about your project. I would love to help or hear about your project. If you are using TF Hub in your project, I would all the more love to hear it. So share your projects with me if you make any, and I would love to hear them. So that was about what I had to say. All over to you, Mehul.
Yeah, thanks, Rishit, for the wonderful session. I think we have, I think so many people joined, and there are quite of interesting questions as well. So, uh, I think that's all. I guess it's. I think we can wrap it now. And if you
Cool.
guys have any questions, so you can feel free to reach out to Rishit anytime. No, as you already shared
Yeah.
about it. So thanks
Yeah.
again for everyone joining, and have a great weekend. And again, as I said, please take care and be safe and take care. Thank you, Rishit.
Wonderful. Thanks for joining. Bye bye.